In this video, we are going to talk about exponential word problems. Here we can have increasing or decreasing situations. Now this formula looks similar to the compound interest formula, but we only use the compound interest formula when we're talking about money that is being compounded. So if we don't have any compound interest, then we don't use that formula. This formula right here is used for increasing and decreasing exponential situations. So let's see what we mean by that. A is your final amount. P represents your initial amount. R is a rate, and it is always converted out of a percentage into its decimal equivalent. And then T represents the amount of time. You'll notice in this equation that we have plus or minus. Now, we only use one at a time. You will use the plus sign when you have an increasing situation, and you will use the minus sign when you have a decreasing situation. So let's see what I mean. On example 1, it says you buy a new laptop for $899. The value of the computer decreases by 35% annually. Part A, write an exponential model for the value of the laptop. This just means write an equation. And we're going to use this formula right up there to help us do that. So our laptop is $899. This is my initial amount, so that's P. And it's 35%. That's my rate. We always need to convert our percentages out of a percentage, and to do that, you divide by 100. So my R value is 0.35. So I'm going to use this equation right here. What we need to figure out is if this is an increasing situation or a decreasing situation. Well, they tell us in the problem that it's decreasing. So I'm going to be using the equation A equals P times 1 minus R to the power of T. For part A, all we need to do is plug in what we know. We know that P is $899. We are subtracting. R is 0.35, and that is going to be raised to the power of T. Part B says use this model to estimate the value if you have the laptop in 5 years. So here T is 5. So I'm going to have A equals 899 times 1 minus 0.35 raised to the 5th power. So I'm going to go ahead and type that into my calculator. I'm going to use Desmos. You can use whatever calculator you like. So when I head on over to Desmos, I'm going to go to the scientific calculator, and I'm going to type in 899, parentheses 1 minus 0.35, raised to the 5th power. Again, this is about money, and so I have to round to 2 decimal places because money is always in terms of dollars and cents, and it would not make sense to have this many decimals that we have over here. And so it's going to be $104.31. $104.31. So that initial investment of $899, it is now worth $104.31. And so it's not worth that much in 5 years. But that is because our technology is always growing. Think about, iPhones when they first came out versus the iPhone 13, right? They're very different. And so the original iPhone is not worth as much today as it was when they first came out. But the iPhone 13, that is worth a lot of money right now. And, in 5 years from now, the iPhone 13 won't be worth as much as it is today. And they use formulas like this to figure all that out. Have you ever traded in your phone and you got money back for your phone? It's because it's still worth something. And so they use these type of formulas to figure that out. If we look at example 2, A town noticed that the number of highway accidents increased by 20% each year. There were 5,120 accidents last year. If this trend continues, how many accidents would there be in 3 years? So let's see. It's increasing. So I know that I'm going to be using the plus sign, so 1 plus R. And it's increasing by 20%. So R will be 20 divided by 100, which is 0.20. Initially, there were 5,120 accidents. And we want to know if this trend continues, how many accidents will there be in 3 years? So that's T. So I'm going to be using A equals P times 1 plus R to the power of T. So I'll have A equals, my initial amount is 5,120 times 1 plus 0.20. And that is raised to the power of 3. So I'm going to have A equals, and I'm going to plug this into Desmos. So 5,120 times 1 plus 0.20, and we were raising that to the third power. And we get 8,847. In this case, we're talking about car accidents, and you can't have a decimal of a car accident. An accident either happened or it didn't, right? There's no in between. So it doesn't matter if it's just a fender bender or if it's a major accident. Here, we just don't, there's no such thing as a fraction of a accident or a decimal of an accident. So let's just round to the nearest accident. So this will be 8,847.